Hey everyone, on this lecture we are going to solve the problem 3 on the section of solve problems on lists. This problem 3 states, define a function with the name duplicate that, given a list of elements of any type, duplicates the elements of the list. So in this function what we need to do is, given a list of elements, we need to return a new list, okay, after duplicating each element of the original list. Here we can see some examples. For instance, if the input is this list of integers 1, 8, and 5, then the output is going to be 1, 1. We duplicated the first element, and we have 8, 8. We duplicate the second one, and we have finally 5, 5, duplicating the last one. If I have this list of strings, where I have the string C and the string forest, we can see how the output is this list, where we duplicate each element, right? We have C. Then we have C again, then we have forest, which was the second element of the original list, and here is C forest duplicated. Finally, if I have an empty list as input, since in an empty list there is no element to duplicate, we are just going to return the empty list as well. Very well, so once introduced this problem, let's see how we can solve it. We begin by creating a new file. Here, let's save this file. We can name this file the same name as the function name. It could be here any name. What is important is that the extension is the URL for the Erlang programming language. We click save. Now here we define the module attribute. Let's name the module the same name as the file name. In this case, duplicate with the final period. And now here let's define this function duplicate. Now in order to solve this problem, we are going to use recursion together with pattern matching. Remember that recursive functions have a base case, or multiple base cases, and we have a recursive case where we make the recursive calls. So here the base case is, what if the input list is the empty list? Well, if the input list is the empty list, we are just going to return the empty list as well, as we saw in the example. And so with this we formalize the base case. The input list is empty, so the output is going to be empty as well. Now what if the list is non-empty? Well, if the list is non-empty, remember that we can represent the list using the head and the tail notation. So if I write something like h vertical bar, this pipe in here, and then we have t, h is the head, the first element of this list, and t is the remaining list, what we call the tail of this list. Right? In this case, if this is the list L, we can represent this list using the head and tail notation, where 8 is the head, as we can see, the first element, and this is the remaining list, it is the tail. So the tail is going to be the list that contains 2, 9, and 5. So why is this notation important here? Well, because if we are given a list in this format, then we have access to one element, which is the first one. And what can we say about this first element? Well, we can say that this element needs to be duplicated, right? So here we can return the list where I have this first element duplicated, and as a tail, what we are going to have. Or this is where comes the recursive approach, and this is why this is a recursive function, because what we can do is we can define the tail of this solution list to be the result of duplicating the tail of this list. And with this, we formalize this recursive definition. So let's see how this algorithm is going to work with this example list. So at the very beginning, 8 is the head of the list, and the tail is this list in here, 2, 9, and 5. So what we are going to return is going to be the duplicated first element, which is 8, 8. And here the tail is going to be the application, again, of the function duplicate. Let's just call it d, of this tail here, which is 2, 9, and 5. So now here, if we come here, this is the application of this same function duplicate. In this case, I have the list 2, 9, 5. I can express this list as 2, where 2 is the head of the list, the first element, and the tail is going to be the list 9, 5, right? And so by definition of this function, we are going to return the first element duplicated, and the tail is going to be the result of applying again the function duplicate with the tail. In this case, the tail we can see is the list 9 and 5. And so here once again we have another application of the same function. Now the list is 9, 5. We can already see that what we are going to return from this, let's put it in here, is going to be the list that we have 9 and 9, and we are going to apply the function duplicate with the tail of the list, right, which is here 5, and this is going to be our new tail. And so as we apply the function duplicate to this list that contains only one element, which is this element 5, notice that if I have a list with only one element, I can express this list using the head and tail notation, where 5 is the first element, the head, and the remaining list, the tail of this list, is the empty list, right? So hence this is going to return here the list where I have 5 duplicated, and then the tail of this resulting list is going to be the application of the function duplicate with the tail of this list, which is the empty list. So notice what we have here. We have arrived to the case where we apply the function duplicate to the empty list. And what is this? Well, this is the base case, right? Remember, if I have the input list to be the empty list, then I'm just going to return empty. This is the base case. So what we are going to return from this is going to be just the empty list. And so here, if I have 5, then 5, and the tail is empty, I'm just going to have here at the end the list 5 and 5. Notice how this list 5 and 5 is going to be the tail of this list 9, 9. So for now I have 9, 9, 5, 5. And so this is what we have in here. This is what we are going to have inside the result of this recursive application. And so I have 9, 9, 5, 5. And then together I have here before 2, 2. So here I have 2, 2, 9, 9, and 5, 5. And finally, I arrive to this last case where I also have 8, 8. So at the end, I have 8, 8 together with 2, 2, 9, 9, and 5, 5, which is precisely the duplicated resulting list that we want. And so with this example, we can visualize how this recursive algorithm is going to work. Thus, we can formalize now the recursive case. So here, what is very important also is that whenever we have a function declaration in Erlang where we have multiple clauses, for instance, this is a clause, this is another clause, we need to separate the clauses using semicolons. Only the last clause of the function declaration is ended with the final period, right? So very important this. So if this is the input list where H is the head and T is the tail, then what we are going to do is we are going to return the list where I duplicate the head. Notice that in this notation, head and tail, we can also have here more than one element before this pipe. For instance, if this is the list as an example, we can see very easily how the head is the 8 and the tail is this remaining list. But we can also formalize this list as the list where the first two elements is 8 and 2, and the remaining list, the tail, is this list here that contains the elements 5 and 6. So this is also possible in Erlang. And in fact, this is what we're using here in the recursive call, right? So here we duplicate the first element, and now here the new tail is going to be the application of the function duplicate, but now with the tail of the original list. And with this we have everything. We end this function definition and this function declaration with the final period. So now let's verify that this function is working right. In order to do this, we need to export this function. The name of the function is duplicate. And the arity of this function is 1. It takes only one single argument. We also need a period here. And with this, we have everything. So we save this file. And let's verify now that this function and this program is working right. So we open the terminal of operating system. We place ourselves in the same path, in the same directory where we have saved this file. In our case, the folder Erlang in documents. Now let's start the Erlang shell. And here let's compile. The name of this model is duplicate. And so once we have compiled, let's begin applying this function. So the name of the model is duplicate. The name of the function is also duplicate. And so here let us begin with the first example where the input list is 185. So if our input list here is 185, we shall expect to see here the output of the resulting list 11, 88, and 55, right? Where we have duplicated each element. And so as we can see, this is precisely what we obtain. If we try with this second example, in which we have a list of strings, we have here the list of strings C and forest. So here C is the first element, forest is the second one. Let's apply this function and we get precisely C, forest, forest, precisely as we had in the example. Finally, we can verify that if I have an empty list, right, this is essentially the base case, we are going to have also the empty list as the result. So with this, we verify that this function is working right, and in fact here we can try with any other possible list. Remember that we can have a list of any type. I can have a list of floats, for instance 2.9, 10.3, and 3.6, right? So if I have this input list of real numbers of float pointing values, here we can see the duplicated list. With this being the solution to this problem 3, we remind the student, as always, that you can download the solution to this problem, as well as the statement, on the downloadable documents of this lecture.